Right, hello there ladies and gents, welcome to another repair video. Today we're going to be working on this Nintendo Switch which has been sent in. This particular console has been sent in because it's got no power. So what we're going to do is we're going to find out what's going on based on what kind of current is being drawn from the Switch. And the way that I'm going to do that is using a USB ammeter. So this is my Unity UT658. No sponsorship, no shilling or anything like that. It just works really well. So we're going to use this ammeter and we're going to try and figure out what's going on with the system. And I'm going to use what we like to call pattern recognition, which is where we just take what we've learned in the past to try and figure out what's going on. So I'm going to attempt to charge it, but before I do, if you are new to the channel and you enjoy this type of content, I would really appreciate it if you make me look a little bit more popular by subscribing and turning on the bell notifications so that you're notified whenever I upload. I would really appreciate it. And I'm also streaming on Twitch now, so there'll be a link in the video description to my Twitch channel. I'd really appreciate it if you head over there and just give me a follow. And if you're feeling really generous, you can stop me from having to eat dust for supper by using a Amazon Prime Twitch subscription. So you can link your Amazon Prime account to your Twitch account, and then you can subscribe to a channel for free. So I would really appreciate it. Obviously, it doesn't cost anything to actually watch the content, but you can use a Twitch subscription to basically subscribe, and it gives the creator a little bit of money. Okay, so we've got 0.19 amps at 15 volts. So they're about 15 volts if you include the voltage drop across the cables. Oh, and it keeps flickering. Huh. What's going on with that cable? Weird. Probably flux inside my cable. Okay, so we've got 0.20 amps, so around about 200 milliamps, which is kind of a strange one. That's leading me to believe that it's probably trying to charge the battery itself. It's probably trying to charge the battery itself, so I don't think there's going to be anything wrong with the power management chip, but there could be something wrong with the P13 USB, which is the video IC. So that's what that's telling me so far. Actually, let's just try that both sides of the cable. Yep. Yeah, okay. Right, okay, so yeah, around about 200 milliamps there. This is the HID board, just to give you a little bit of reference. So this is going to be the limited edition Animal Crossing, which is always the HID board. I think all of the limited edition ones are the HID 001. I could be wrong. I think they are. But what I'm going to do is I'm going to take it apart, and while you're waiting for that, you could give the video an early thumbs up and make it look like you enjoy the content. If you do it now, then basically by the time you actually finish the video, you might have forgot that you've pressed the thumbs up button. So you might not actually remove it when you realise how boring I am. So yeah, there we go. Okay, so I'm going to take this apart. That screw's a little bit stuck. Alright. That one's a little bit stuck. Okay, fine. I'll show you how to deal with that in a second. Let me just get the rest of these screws out. Got a little bit of bending going on. Not much, but very slight bending. Typical Nintendo Switch. And bear in mind, these are not that old. The HID board. It's not that old. Okay. Just one more screw and then I can deal with that one that's stuck in. Okay, so what I'll do when I've got a screw that's stuck is I'll try and take the case off, or rather I'll take it off as if I'm taking the case off. Put a little bit of pressure just on the screw thread, which is going to be under here, and then just unscrew it with pressure. There we go, and that is out. There we go. Awesome. And then I can just pop the actual screw out, and that's job done. That is job done. There we go. Excellent. Okay, so next I'm going to just remove the back plate, and then I can go ahead and do a few more preliminary tests before I take the motherboard out of the housing. And that's not the right. Whoops, that's not the right screw. Someone lose a screw. Well, I guess I'll replace that. I'm not going to put that screw back in. That is for certain. Okay. Here we go. Okay, so someone's definitely been inside. And alright, so what I can do is I can take a bench power supply cable which I made. Basically the bench supply cable is basically just the insides of a battery for the Nintendo Switch. And what that allows me to do is, number one, it allows me to power the Switch without having to have a fully charged battery all the time, which is very inconvenient to keep having to charge a battery. But it also allows me to see what kind of current is being drawn directly from the system. So when you plug the charger cable in, it can give me a general idea of what's going on, but it's going to try and charge a battery at the same time some of the time. So as long as the charging circuit's working, it's going to give me the readout for whatever's being drawn by the battery, not by the system. So basically by using my own bench power supply cable, which is literally, like I said, just the insides of a Nintendo Switch battery, so that goes there, and it's just a little circuit board soldered onto some wires. That's soldered onto this quick change, and then that's onto the banana jacks. And the reason it's on a quick change is because I've got different leads for different things. So for example, this one here is for the Xbox One S, so I can power the One S from the same cable. So I'll just unplug that, plug that in, job done. And that is a very handy little thing to have. Okay, so I'll plug that back in, and I've got my bench power supply set to 4 volts. So I'm going to set it up so it's showing up on the screen. And I'm actually going to change the bench supply, and I'm going to put out 4.2 volts. And the reason for that is because when I plug the charger in, it's not going to want to try and charge my power supply. So I'll set that to 4.2 volts, and I've got it capped at 2 amps. So 2 amps is more than enough to run a Nintendo Switch. I don't want it to draw too much current. So I'll just plug them into there. And then when I plug this in now, it's going to give me a rough idea of what's going on. I plug them in. We get no immediate current draw, which means BQ24193 should be good, which is the battery management IC just down here. That charges the system. Or rather, yeah, that charges the battery rather. So let's prompt it to boot. Okay, 90 milliamps, 169, 300 milliamps, 400 milliamps. That is booting. That is booting, or rather that's attempting to boot. A little bit low on current draw, but that appears to be attempting to boot. Okay, and then it fails. Oh. Okay, is that in a boot loop? I believe that's in a boot loop. Alright, that is in a boot loop. So let's do some tests with the multimeter, and I'll pop under the microscope for this so as we can all see. And here we have the power management IC. So the part number for this is M92T36. Basically that controls pretty much everything on the board, so power goes through that before anything else. I'm just going to put the multimeter into continuity mode. So that's the mode that's going to beep when we complete the circuit. And I'm going to test some of the capacitors around here. Start with this one. Always start with this one on the bottom. And the reason for that is because that is generally a dead CPU. And we just basically give up there and then. So that doesn't appear to have any continuity to ground. Good. 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 Okay, and all of that appears absolutely fine. So let's check down here. This is the BQ24193 area. So this is going to be the battery charging circuit. We have continuity on the coil. That's good. Let's just check the caps around here. And that's good too. Okay. Kind of irrelevant, but just confirm the fuse is good. And let's check this filter. Okay, that's not normal. So we've got a line here. Oh, well. Oh, okay. Never mind. Well, it was showing up as short. I was going to say then, I've never come across that. Whoops. Left my mark there. Yeah, I was just about to say then, that was a bit weird. Alright, well, never mind. Let's just check some of these caps around here. Absolutely fine. Alright. So this appears to be boot looping, but there's no display when it is boot looping, which is kind of odd. So one thing I would expect, even if there was no display, would be to at least have a backlight, and we're not even getting that by the look of it. I've just disconnected that eMMC, the NAND. That's basically the system storage, just to make sure that it's not that what's causing it. Let's not use that. Let's use the bench supply. Because if we've got no eMMC installed, then it wouldn't display any backlight at all. And we are still getting current draw there, but it's still boot looping. So one of the things with a boot loop is it's obviously trying to turn itself on, but it can't quite get past all of the checks. So it's just looping, and it's just trying to start again, which is obviously not normal. So we need to figure out why this is boot looping, and also we need to figure out why it's not actually displaying on the screen. So I've got a feeling that it's probably going to be something to do with one of the two main chips, which is going to be M92 T36 or P13 USB on the back. But I could be wrong. I've certainly been wrong before. So you can see that it's... Sorry, no you can't, because the screen's off, never mind. I turned the bench supply off. Well, that sucks. But yeah, it is still trying to turn on, as you can see now in the top left. It's still trying to turn on, but it can't actually turn on. So even though M92 T36 just here is showing up as short, it could still be bad. Sorry, not showing up as short, it could still be bad. M92 T36 doesn't always fail short. I do keep trying to turn it on as I'm disconnecting things, but I don't think it's going to make a difference. So if there's some background noise as well, it is raining outside, unfortunately. So I'm removing basically everything what needs to be removed, or rather what can be removed without it affecting whether it's going to turn on a display or not. That's going to include the fan. So one thing I could do is I could attempt to turn it on, watch for the current draw, and then try and feel for some heat, and just see if we get any kind of heat output. 400 to 500 milliamps should be putting out some kind of heat from somewhere. Alright, let's get the board out. Let's forget about seeing if it's going to boot. It's not going to boot for sure. So let's just get the LCD out. Safest way to do that is to unclip it, get some tweezers down the side, and just flick. That is what I found to be the safest way. Okay, this board don't want to come out, so I'll just loosen off the fan. And then the fan can move around freely, or to a certain extent. The fan will move freely, and then the board should pop out. There we go. Beautiful. Okay, so I'm not seeing any signs of any kind of... Oh, here we go. Here we go. Someone's done something naughty. Well, okay, I think we've found our problem. Yeah, kind of don't know what to say about that. But I think this might be an issue. How on earth does this happen? How does this happen? Wowza. Alright, so there is going to be a big problem. I didn't expect that. That kind of stopped me dead in my tracks there. But how do you do this? Like, seriously, like, how do you do that? I think someone might have got a little bit rough with the tweezers there. I did not expect that. But what I need to do is just inspect the rest of the board now and just see if I can see any kind of further damage which might have been caused. Yeah, that should probably be announced on the during the booking process, I think. Alright, so there's no more damage this side. Right, so yeah, that's dented. So this plate here is dented. Under here is the Wi-Fi IC. So why was someone messing in this area? In fact, why has someone had this board out full stop? Right? Because I can't see any issues apart from what's been damaged. Why has anyone had this board out? It doesn't make any sense. Okay, it's not water damaged. Look, very clearly it's not water damaged. It's not had a replacement port. M92T36 has not been replaced. That is factory lead-free solder. BQ24193 has not been replaced. The fuel gauge has not been replaced. That's a Max 17050. P13 USB or PI3 USB. It seems to trigger people when I say P13. That's not been replaced. Charger port, definitely factory port. Why has this device been messed with? Why has anyone been inside this console at all to do that kind of damage? I mean, yes, it might still not be turning on. But yeah, I don't understand why that's been damaged. How that's been damaged. That is very visibly user damage. That is not caused by some sort of short. Yes, you could get a blown coil. You could get a coil explode technically with a short. But you're not going to get that kind of damage with a short. It's going to either burn it, it's going to blow a hole in it, or it's going to blow the component. It's not going to scrape the board like that. That is definitely user damage. And the problem with this is it's kind of multi-layered. And that looks to me like multiple layers are gone. So we've definitely got a trace here which is going to need restoring, but we need to figure out what's going on down here before we go any further. So I'm going to go ahead and just clean this up a little. So I'm going to use a bit of hot air and just remove this component that's damaged completely from the board. like so. Drop a bit of isopropyl alcohol there, and what the isopropyl alcohol is going to do is it's going to allow me to see this a little bit more clearly. So at the moment I can't tell if that's gone through more than one layer or not. It's very difficult to tell right now. So I'm going to need to scrape it a little bit. These traces here are technically still there, I think. But the problem here is that the trace here could actually be shorting out to something else underneath because of how damaged it is. So usually there's a protection layer, and that's called a substrate. But I've got a feeling that the substrate is going to be gone, even if the trace isn't, just because of how deep it's gone. So it's going to be rather difficult to actually try and get this sorted. I'm going to just try and follow this and try and figure out what this trace is for. So we've got a resistor here, and then it goes to a wire. So it comes down here, and it goes through the board down here. And then if we flip the board over, it appears to be something on the Wi-Fi. Yeah, it appears to just be for the Wi-Fi antenna. So it looks like it goes there, and then that goes through to the other side of the board, and that's what gives you the signal. So it looks like it comes up here. I would say it comes up here and then to somewhere here where it controls the signal for the Wi-Fi IC. That is my best guess, but that's not really the problem. The problem is whether that's shorting out on something else. So what I'm going to need to do is, for a start, I'm going to need to break this line. I'm going to need to break this line just in case it is shorting out. And I'm going to have to basically resolder another trace to it. Or rather, in this case, it would be a jumper wire. So the first thing I'm going to do is just pull back some of this trace here. I'm going to remove some of this Wi-Fi antenna, or the trace for it. And I'm going to basically isolate that line, if I can. So the trace is literally just glued to the substrate. So I should be able to lift it up without causing any more damage to the board. I mean, let's face it, I don't think you can cause much more damage to this. But I want to isolate this and just bring it back a little bit, because that's going to give me room to dig through these layers and just try and basically prevent them from shorting out across each other. I'm not saying they are, but they could be. So I'll isolate that side. And I don't know if that's actually isolated or not. I would say it probably is now. So I'll just dig that trace out. And then I'm going to do the same for this side as well. So I'm going to isolate it this side as well. And what I can do is, once I've actually fixed everything, or if I can fix everything, then I can basically just reconnect that trace using a jumper wire. So some enamel wire, just to rejoin the trace and complete the circuit. Because right now this is going to have no Wi-Fi. I can't remember if that antenna is for Wi-Fi or Bluetooth, but that's kind of irrelevant. The main issue right now is just trying to get it to turn on. So all of this around here is going to be a ground, so I'm not really bothered about damaging that. I just want to isolate this trace and make sure that it's not going to short out on anything. Okay, let me just clean that up a little bit. I mean, I'm using a sharp blade here, and you can see how difficult it is for me to pull back these traces and cause any intentional damage to it. So you can imagine the kind of force that's going to have been done on this. Now the question is whether or not those layers underneath here, because this is very visibly multi-layer damaged, and you can see 1, 2, 3, potentially 4 traces or 4 layers which have been exposed here. So the problem here is not just that we've got a damaged line, but it's also going to be the fact that there's multiple layers damaged, and it all depends on what's actually down there, because we don't have schematics, so I can't figure out what's actually going to be connected there, whether it's just going to be ground all along or whether it's going to be traces that go elsewhere. There we go, that's isolated now. This here, like I say, is just going to be a ground, so I'm not really worried about that. I am going to move a little bit of it out of the way though, so I'm going to peel back some of this ground. So you can see here that we've got this black stuff here. This is the substrate. I'm just going to peel back some of this just so as it's not going to cause any issues. Like I said, I don't need to worry about that. Same with this one here. So I'm going to peel back some of this ground layer here as well. I'm just going to basically get rid of that. And I'm going to come a little bit further up on this antenna trace. There we go. So this looks a mess, but I believe it's probably essential. So let's clean that up. Might end up having to replace this IC as well. I believe this is probably the backlight IC, which would explain why it's got no backlight. If that coil is damaged, that coil is basically going to be boosting the voltage to allow the backlight to actually work. So you're going to have an input voltage one side and an output voltage the other side. And if that coil is basically damaged, it's not going to boost. So I'm going to peel this layer back. This again, like I said, is just going to be a ground, this top layer. I can tell that just based on where it goes. So if you follow this up here, it goes all the way along, but it also comes down here, it goes round, and then to here where I've cut it off. So not really worried about that. If it breaks 2 sections of ground and causes one half of the board to not have ground, I'll just run jumper wires and reconnect the ground. But I can confirm that with the multimeter. The edge of the board is normally going to be a ground. And conventional PCB design would put a ground at the edge of the board, all the way around the edge. Which is why it's so difficult to get off as well. Okay, so there's that layer cleaned up a little bit on that side. Let's do the same this side. Let's get rid of some of this ground here. So that's going to be ground as well. All of this down here. It's going to be ground. So I think you can kind of see what I'm doing here. Peeling back the layers to try and basically separate them. Okay, let's clean it up a little bit more. So that looks to be all separate now. So we've got a layer here, this is the top layer, and then we've got another layer just here. So you can see the outline of that, and then you've got another layer, and then a final layer. I believe these probably are all ground, but just to be safe, I do want to make sure that they are isolated. Let's just check these. So I'm going to pop the multimeter into continuity mode, and I'm going to check all of these layers and just see what we've got in terms of a ground connection. So multimeter is in continuity, one probe on ground. We've got a ground there. And we're going to ground there. Ground, ground, ground. Nothing because there's nothing there. And interestingly, oh, hold on. Yeah, never mind. Okay, it was just a connection issue. Okay, it is all ground, interestingly. So that peeling back wasn't actually necessary, but this peeling back on the trace would have been, because we don't want to short out that Wi-Fi antenna to ground. So I think that is probably going to be fine in terms of isolating that layer. So what I want to do now is basically just protect it and prevent it from shorting out. So I'm going to use some conformal coating. Basically that's just going to isolate the ground layer and basically prevent it from shorting out when I run a jumper wire across. The jumper wire is enamelled, but just to be safe, I would much rather protect the area. So I'm just going to spread this out. Okay, bring that up there. You don't want it too thick because otherwise it won't cure. I'll just bring that out and just basically move it along. So it's just got a nice thin layer. Also down here as well, let's just protect this. Okay. Then I'm going to just clean up a little bit of this here. So I'll just get rid of some of that. Like I said, we don't want too much here. Just enough to protect it. And then I'm going to use a UV pen to cure this. So it's actually a 405 nanometer laser, which I use. That's the wavelength which the UV mask cures on. So I'm just going to run this laser across for a few minutes just until it cures. Okay, that should be good. We should be fine with that. So what I'm going to do now is just check and make sure that it's cured just by giving it a little prod with the tweezers. And yes indeed, a little bit of fluff stuck in there, but that's fine. That is cured nicely. Okay, so next I need to actually replace this missing coil. So the coil I can just take from pretty much anything, any board. So you can see here that we've got pretty much the same circuit, it's just a little bit differently designed. So I'll remove that coil from there and I'm going to place that just here. It doesn't matter which way this goes round. It's going to be the same rated coil because the backlight is going to be exactly the same. I believe it's the backlight circuit, but it is the same circuit, it's just designed slightly differently in terms of layout. That is literally it. Alright, that's soldered. Now the issue is, what is going on with this chip? Because as soon as I put any heat on that, it went a little bit weird. So we may end up having to change this chip, I'm not sure. That could just be the paint, because there is a layer on top of these chips. It could just be the paint, or it could actually be that the chip is damaged. So I'm not going to worry about the antenna for now. I do want to just see what's going on when I try and power it on. And I will straighten up that coil as well before I finish the job. So let's see what happens when I prompt to boot it. Because it's not in the case, I don't have a power button. So the way I'm going to prompt to boot it is just with the charging cable. So if I just plug the charging cable in, it will prompt it to boot. Or it should prompt it to boot. but it's not. Ah, there we go. Dodgy connector. Alright, so what's going on with the current draw then? Let's have a look. Let's see how this behaves. So we're looking to see if it's going to drop down to 0. It's still dropping to 0. Okay, yeah, it's still boot looping. Something is still going on with this, but let's just see if we've got any kind of backlight at all. Probably not. Didn't think it would be that easy, to be honest. It never is. There we go, we get a backlight. And it does try and boot. Oh, it's actually turning on. Okay, so why is it shutting itself off? No, it's not. It's going into standby. It is booting. Yeah, it's staying on. Excellent. Fantastic. I guess it was that easy. Wow. All right, well, let's just sort out what we need to sort out now. So, what I mean by that is we need to sort out that antenna. And we also need to flow that coil down properly. All right, well, that's good news. That is very good news. So, like I said, we need to fix this now. So we need to expose some of this trace. So we're going to give somewhere for it to solder to. And then we're going to do the same on this side. So we need to be able to expose the copper on the trace itself to be able to solder to it. Difficult to expose just that part though, because it is a very, very small area. There we go. Perfect. So we've got somewhere to solder to now. So I'm going to get some jumper wire and I'm going to use 0.1mm. So I know 0.1mm does seem very small, but in micro soldering, it's actually quite big. Okay, and what I need to do is add some flux first of all, like I said. So I add some that side. Add some that side. And then I need to tin the area using some leaded solder. Okay, so that trace is tinned. That's tinned as well. So by tinning it, it's going to make it easier for us to actually solder to. Flow some solder onto this coil as well. Spin it around, make it easier. There we go. So like I said, I need to use some jumper wire now. And this is going to be 0.1mm. And we're going to start on this side. So I'm going to just tin the edge of it. Just by running the iron over. So this is enamel wire, which means that it's not going to short out on anything that it crosses over with. Okay, so there's that side done. I'm going to run it straight down. Expose this part. And I've just lost the jumper wire there. Let's just expose it before I solder it on. Just tack it down. So I've just tacked it down this side. It was just off camera. This is a very thin trace. Okay, that's tacked back down. I'm going to hold that in position. Run that jumper. That side's done. So now I can use the blade and just trim that. Beautiful. And then I'm just going to try and secure this side. So I'll just add some more leaded solder to the iron. Hold that jumper wire. and just add some solder to it. There we go. That is absolutely beautiful. Okay, let's clean that up. So burnt flux is always awkward to clean, so just add a little bit of heat and then we can clean it off using isopropyl alcohol. There we go. And as you can see, that coil has some nice shiny joints as well now because he's got some fresh leaded solder there. So we'll just clean that. Let's just soak up the rest of this isopropyl alcohol. Alright, so the reason that I do that is to make sure that there's no isopropyl alcohol or anything that's going to affect the conformal coating over the top of the jumper wire, because I want to protect this now. So obviously we've got an exposed trace and we don't want that. So again, I'm going to add another layer of conformal coating, and that's basically just going to glue this trace back down as if it was never damaged in the first place. Just going to spread that out. Like I said earlier, we don't need much here. I do want a thicker layer where the jumper wire has been installed. I want to make sure it's nice and secure, even if someone takes this board back out for any reason. Hopefully they don't do the same thing again. I honestly don't know how they could have done that, or even why the board had been taken out in the first place. There was no reason for it by the look of it. Like I said, it's not been water damaged, it's not got any kind of power management issues or anything like that. It's very strange how this board has come out in the first place. It doesn't make any sense to me, but that being said, hopefully this is going to work fine now. So I'm going to cure this again. Okay, and that should be good. Okay, and all that's left to do is to reassemble and then give it a full test. So I'm going to clean off this thermal paste before I go any further. That's not needed. We're going to put fresh on. There we go. Beautiful. I'm not sure if there's going to be any charge in this battery. Nope. So let's see what kind of current. Okay, we do get a battery logo though. Let's see what kind of current is being drawn when this thing ever wants to charge. There we go. We get 210 milliamps, and that should start to climb as it charges. But for the purposes of testing, like I said, I'm not going to do that. I'm just going to literally use my bench power supply, because it means I haven't got to wait for half an hour for that to charge up. Okay, that's acting weird. Why are you acting weird, Mr. Switch? Okay, that was a little bit odd. Okay, let me try disconnecting that antenna. Check again. Yeah, the boot sequence isn't normal. Yeah, that's not a normal boot sequence. That's not booting up properly. It's very intermittent. That could be the bench power supply, potentially. Let's charge the battery. Let's see what goes on when I've got a fully charged, well, not a fully charged battery, but enough to turn it on. Yeah, let's do that. Okay, so I'll pause the video. I'll resume when it's charged enough to turn on. A few moments later. Okay, I'm giving this around about half an hour. And yeah, it's fast charging. So let's take a look. Oh, huh. What? Don't be like that. Yeah, it is still, however, not working properly. Something is still causing this to boot loop, but it wasn't doing that before I run the jumper. It's also not working on the touchscreen either. Yeah, it's still acting strange. So I'm not seeing that first boot logo. Okay, and the touchscreen isn't working. Right. Let me connect up a Joy-Con. Ugh, it's just gone off on me. No, it hasn't. Right. It's still acting strange. So it's not working with touchscreen. So touch isn't working and it's still acting a little bit odd. Right, I did see the Nintendo logo slightly then for a second. I think that's taking a little while for the backlight to initialize. Oh. I know what's going on. The backlight's shutting off. That IC needs replacing. That backlight is shutting off. It's not boosting properly. I think I can see what's going on. Okay. Right, so hopefully my theory here is correct in that we need to replace that IC. I believe it is linked to the backlight. I could be wrong, but I'm pretty sure that is a backlight driver. So I'll add some flux there. And just remove that chip. Alright, technically I don't need to remove the solder because the solder paste is going to basically fill it and it's going to reform even balls. It's going to fill all the gaps in. So technically I don't need to clean it. That's a good thing about using solder paste. Just like that, look. And then you got even balls. Okay. Let's get rid of this bit of stray wire from off the wick. Okay, let's give it another test. Backlight and LCD only. Yes, we get a backlight. Is it going to shut the backlight off? No, it's not. Now it's behaving normally. Okay, let's reassemble. Okay, that's back together enough to test. Let's prompt it to boot. We now get the initial Nintendo logo, which means that the backlight is turning on properly when it should. It's not taking forever to actually power up. I think that's what was happening. And the touchscreen is working now as well. Fantastic. Beautiful. Okay, so let's just do a few basic tests then. So I've already confirmed it charges. Let's see if it loads again. It does indeed. I know already that this blue controller is connecting. There we go. Let's use this one. Yes, I know it's taken apart. I was having some issues with it. There we go. Hey, there we go. Moment of truth. Wi-Fi. Yes. Wireless controllers. Yes. Fantastic. It's all working. Absolutely brilliant. Charging. Charges that side. 0.95 amps. Fast charging. Flip it around. 0.95 amps. Thereabouts. Fast charging. Excellent. Beautiful. Everything appears to be working. I just need to test it on the dock and then that's pretty much good to go. Okay, so I've got a dock here. It's a little bit tight. I unrooted everything last week and I haven't had a chance to actually reroute it yet. Do we get a green light on the dock? We do. No. Let's try doing it again. Yes. It just confused it because it wasn't actually plugged in and the TV wasn't turned on. There we go. It's working absolutely fine. Absolutely perfect. Right, all that's left to do on this now is to just reassemble it and obviously put it back together. I will give it a full test. I'll give it a full charge, make sure it's all charging properly, reboot it a few times, etc, etc. But obviously for the purpose of the video, it's working. And as you can see, doesn't appear to have any issues now. So absolutely great news on this. I honestly can't explain how this has happened. I really can't. I really can't explain how it happened. So it was sent in for no power. It turns out that it had power, but it was boot looping. And it wasn't nothing to do with the typical things that we see when we've got no power. So it turns out that someone has tried to do something to the board and they've stabbed through it. Well, the only thing I could probably think of to explain it is that maybe they've taken the board out and they've tried to get some tweezers or a screwdriver and tried to pry it out from that side and they've slid underneath and stabbed it. I've seen it before. I saw it a couple of weeks ago around the LCD connector. Yeah, I just can't think of anything else that could have caused that. Obviously, it's user damage. And the person who done this has obviously got to pay the price for it now. Word of advice, don't try and take the motherboard out using tweezers. It's never going to end well. It's a very thin board. It's not going to end well if you try and use tweezers. So, yeah, obviously just to summarise, I've had to peel back a few layers. Probably didn't have to, but just as a precautionary measure, I did that. And then I run another jumper wire to, I believe, one of the antennas to reconnect that trace. Replaced the backlight driver, and it's all working. I believe that's a backlight driver anyway. I could be wrong, but you know, I'm pretty certain that it's a backlight driver. But by replacing that IC, obviously, I mean, you see where I replaced the coil, that it was basically popcorn in the chip, and that was probably because of the prior damage. And obviously, by replacing that chip with one from a donor board, it's working absolutely fine. So the backlight issue was causing the boot loop. It was also causing the no power. And yeah, this console's working again. So I'm super, super happy. Hopefully it's going to be a good week. Hopefully you enjoyed the video. And hopefully you learned something along the way. But that's going to be it for this video, guys. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to answer. And if you want to organise your own repair, you can do so by getting in touch using the website in the video description. There's an online booking form where you can just fill that form out. There's some price lists on there of some of the more common repairs and things like that. If it's something not so common, get in touch. I'll give you a custom quote. Also, if you enjoy this type of content, be sure to hit the subscribe button and turn on bell notifications so that you're notified whenever I upload. You can also support me by becoming a Patreon supporter using the Patreon link in the video description. You can become a channel member using the join button down below, and channel members and Patreon members get early access to videos. Please, please, please don't forget to follow me over on Twitch if you want to catch some live streams. I do this kind of stuff on live stream. I also game on live streams as well. I've just started doing that and taking some time out for myself because I spend way too much time in this workshop. But that's going to be for this video. Thank you very much for watching, and until next time, I'll see you later.